everybody by surprise, and during that time there was an outburst that led to a dramatic increase in its brightness. For the past several days, people in the southern hemisphere have been taking some incredible images of comet C 2025 R2 Swan.
The announcement sent a thrill through the astronomical community. The James Webb Space Telescope had seemingly detected artificial lights in R2 Swan. At first glance, the claim defied every assumption about alien detection and observational astrophysics. To contemplate that a comet, roaming our solar system, might harbor regions illuminated by technology is to stare directly into the realm of science fiction made real. Yet here we are, forced to imagine what that would mean, how it might have been observed, and what consequences ripple outward from such a possibility. Before we start, hit the like and subscribe buttons for more exclusive news. R2 Swan, also known as Comet C 2025 R2 Swan, had already drawn attention for its unexpectedly bright appearance and active behavior as it journeys closer to perihelion and toward Earth. It was discovered via the Swan instrument on the SOHO spacecraft, which monitors the solar wind and occasionally stumbles across comets passing close to the sun's glare. As R2 Swan gains visibility with ground and space-based telescopes, it has drawn observers aiming to chart its tail, measure its gas and dust production, model its orbit, and predict its brightness. Against that backdrop of natural curiosity and cosmic dynamics, the new claim elevates the comet from a fascinating wanderer to a candidate harbor of something entirely different. The essence of the detection lies in an unexpected excess of light in certain narrow spectral bands, appearing spatially distinct from the comet's coma and tail. In the analysis, astronomers working with Webb data flagged anomalies inconsistent with known emission lines or reflected sunlight from dust. Instead of following the smooth gradient one expects from the expansion of gas and dust outward from the nucleus, portions of the inner coma showed concentrated patches of illumination, with spectral signatures reminiscent of engineered lighting. These patches did not align with solar reflected lines or typical cometary excitation emissions. They bore the hallmark of energy input from some directed source. In other words, the light was not passive. It looked on. To believe this, scientists had to rule out a battery of alternative explanations. Comets can exhibit jets, outbursts, and irregularities in dust and gas ejection. They can carry embedded minerals that fluoresce under solar ultraviolet or cosmic rays. Micrometeoroid impacts or sublimation of volatile pockets can also cause localized brightening. Webb's instruments, especially in the near and mid-infrared, offer precision but also confront challenges. Stray reflections, instrument artifacts, cosmic ray hits, and scattered light from the coma itself all must be managed. The team therefore conducted cross-checks with simultaneous observations from other telescopes, exploited multiple filters and spectral channels, and looked for reproducibility across time. The patches persisted. Their geometry and brightness could not be explained simply as comet jets or thermal hotspots. If the interpretation holds, it suggests that somewhere on or within R2 Swan there exists an engineered light source, perhaps a network of lights on a surface, a probe embedded in the nucleus, or even a hollowed interior in which bases or infrastructure exist. The mere possibility that a comet, long considered a relic of the early solar system drifting inwards under gravity, could host structures or equipment challenges our most deeply held expectations. Comets are dynamic, volatile, and physically punishing environments. To survive, let alone build sophisticated lighting, would demand mastery over extreme cold sublimation pressure, micrometeoroid bombardment, and orbital stresses. What could such structures be? One scenario imagines that an extraterrestrial probe or habitat was sent to or encountered the comet in the distant past. As it traversed interstellar space or the outskirts of a planetary system, it could have planted monitors or power units that now activate or persist. Such devices might use the comet's volatiles or solar energy to operate, combining energy harvesting with the protective shielding provided by ice and dust. Another possibility is that an alien civilization used the comet as a vehicle, a stealthy, dark, cold ship, either to traverse space or to hide from detection, and only now its lighting is leaking out. Alternatively, these lights may mark resource extraction, communication beacons, or scientific instruments maintaining operations. Whether the lights are large, kilometer scale, or small, probe scale remains unclear. The spatial resolution at the comet's distance and limited photon counts leave room for ambiguity. The lights might be intense and localized, or diffuse and weak. The contrast ratio between artificial lighting and surrounding emission is quite steep, which suggests a significant energy source behind them. In conventional engineering terms, to be visible from Webb's vantage, they would need to emit enough power, in narrow bands, to outshine the ambient glow of the comet in those bands. That suggests a non-trivial power budget, perhaps generated by solar panels, nuclear reactors, or advanced energy technologies unknown to us. The location of these anomalous lights is also telling. They are reported not at the outer coma or tail, but in regions close to the nucleus, where the dust and gas density is highest, and where surface activity and outgassing is strongest. That means any structure would need to contend with sublimation, jets, shifting mass, and perhaps even fragmentation of the nucleus itself. If the structure is internal or subsurface, it could be shielded to some degree from solar heating and volatile loss. If external, it would need robust thermal and mechanical resilience. The comet's rotation, tides from solar heating cycles, and torques from outgassing would constantly stress any artificial installation. Perhaps the most profound implication is this: if even one comet in our solar neighborhood carries artificial lighting, we must reconsider the frequency, distribution, and boldness of extraterrestrial presence. Comets travel in elongated orbits, traverse vast distances, and sometimes come from the outer reaches of the solar system or even beyond. A lighting-equipped object in that regime hints at a civilization capable of deploying infrastructure across interplanetary or even interstellar distances, operating covertly or in deep space without drawing attention. It suggests that our methods of SETI, radio listening, optical pulsing, planetary biosignatures, may overlook entire classes of extraterrestrial activity in small, cold bodies. It raises the provocative notion that intelligent life does not confine itself to planets, moons, or orbiting satellites, but may seed or inhabit comets, asteroids, and other minor bodies as way stations, communication nodes, stealth platforms, or energy sources. In the more immediate domain of comet science, the detection of artificial lights in R2 Swan would upend foundational assumptions about cometary behavior. For decades, comets have served as natural laboratories, relics of primordial material, carriers of water and organics, message bearers from the early solar system. Scientists study their jet structures, dust-to-gas ratios, isotopic composition, magnetic fields, and dynamics to trace planetary formation and solar system evolution. If some comets are masked habitats, their observed properties may include non-natural perturbations, unaccounted energy output, or even material replacement. Models of outgassing, tail formation, and dust ejection may need revision to account for dark structures or subsurface engineering. A related implication concerns the risk of misinterpretation. Throughout history, telescopes have occasionally recorded anomalies, transient brightenings, unexplained light curves, unknown spectral lines that later found mundane explanations. Calibration quirks, cosmic ray noise, instrument ghosts, observational bias. Embedding a credible detection of artificial lighting in that tradition demands rigorous validation. The Webb team must account for instrument artifacts, stray scattering, calibration uncertainties, and line-of-sight contamination. Only if these can be excluded can the artificial light hypothesis stand. The stakes are high. False positives would erode the credibility of future claims and fuel skepticism. A detection so extraordinary demands equally extraordinary proof. Thinking ahead, the detection invites rapid follow-up efforts. Ground-based telescopes could attempt complementary observations in visible, near-UV, and radio wavelengths to look for correlated fluorescence, emission lines, or thermal signatures. Radar mapping, where feasible, could interrogate nucleus structure, looking for density anomalies or artificial reflectors. Space missions, though expensive and lengthy, might be proposed to rendezvous with or fly by R2 Swan in order to directly image or sample the illuminated zones. Even small CubeSat hitchhikers or piggyback probes could be considered to fly near the comet and relay high-resolution imaging or spectrometry. The policy, philosophical, and cultural implications cannot be overstated. Should the detection hold, humanity would face its first credible sign of extraterrestrial engineering within reach of our spacefaring capabilities. The question of whether we attempt contact, examine or approach the structure, or broadcast to it becomes urgent and must be weighed with care. The mere knowledge that we are not alone, and that non-Earth intelligences may hide within comets, would forever alter our self-conception, our cosmic narrative, and our strategies for space exploration. But beyond the spectacle lies deeper scientific promise. If the lights are tied to power systems, they may produce heat, waste radiation, or modulation indicative of communication. Analysis of their spectra could reveal technological design, bandpass filters, pulsed modulation, narrowband emission lines, or energy-saving schemes. Studying how such lighting behaves in a cometary environment could teach us far more about alien engineering than detecting an exoplanet signal ever could. Because this is not remote, it is intimate, a body within our reach. It offers a laboratory for comparative astroengineering, constrained by known physics and exposure to solar environment, yet in a domain hitherto unexplored. Skeptics will rightly demand extraordinary levels of verification. They will point to instrument calibration uncertainties, thermal anomaly modeling, contamination from dust scattering, and unknown fluorescence physics in complex organic compounds. They will ask for corroboration by orthogonal means, repeated observation epochs, multi-wavelength consistency, and eventual in situ inspection. That is science's way. Suspect the extraordinary, insist on reproducible measurement, and treat every new claim as provisional until confirmed. The very notion also pushes us to reevaluate search strategies. Should comets, asteroids, Kuiper Belt objects, or interstellar objects become high-priority targets for artificial signature surveys? Up to now, SETI has generally focused on radio signals, narrowband optical pulses, or planet transit signatures. But perhaps our blind spot has been the small, dark, and drifting bodies, ideal stealth platforms or nodes. If R2 Swan is not alone, then there may be a hidden network of engineering on comets across the solar system, awaiting detection. We may need to retool our observatories, survey strategies, software pipelines, and signal processing algorithms to look for narrowband, pulsed, or spectral anomalies in tiny bodies rather than static stars. Imagining specific scenarios, one can envision a civilization dispatching a cloud of microprobes to wander comets, docking with them, and embedding minimal lighting and sensors. As the comets approach inner regions of a planetary system or cross paths with stars, the microprobes might activate, communicate, or study planetary systems. The lights we see could simply mark diagnostic modules, communication buoys, or minimal beacons. Because comets offer camouflage, dark, cold, irregular shape, they might be ideal containers for long-duration stealth platforms. Their unpredictable orbits and infrequent activity mask presence until one is illuminated by a telescope. The fact that we happen to catch one in a high-energy phase gives us a chance. Moreover, perhaps advanced civilizations favor such platforms precisely because they minimize maintenance, use local resources, ice, gas, and remain inconspicuous until needed. If instead the structure is large and artificial, perhaps an extractive or observational facility has colonized the comet. It may harvest volatiles, collect solar energy, or use nucleus materials for construction. The lights may belong to energy refineries, communication towers, or habitat modules. In that event, a more ambitious narrative suggests that comets act as mobile facilities, moving laboratories or mining stations that traverse the solar system or even jump between systems, if some mechanism existed. That would imply technological reach well beyond what we have imagined, engineering at cometic scales, power management in extreme vacuum and cryogenic conditions, and navigation control within the dynamic environment of the solar system. Yet the simplest working hypothesis may lie somewhere closer to a probe or cluster of probes embedded in the nucleus or beneath its crust. Their lighting may serve internal illumination, diagnostics, or signaling. They may tap internal heat, use thermoelectric conversion, or deploy miniature reactors or photovoltaic arrays exposed through windows or apertures. The observed light patches could be windows or apertures in a subsystem, or reflectors, or narrow beam emissions leaking through layers of ice. The patchiness suggests not an entire shell, but discrete nodes or components. Another intriguing possibility is temporal variability. The lighting may turn on and off, modulate, pulse, or vary with rotational phase or solar exposure. If repeating periodicities are found, that would strongly support an engineered origin. Astronomers will comb the data for periodic flickers, phase-locked modulation, or multispectral correlation. If those emerge, the artificial hypothesis gains weight. If not, the possibility remains tentative. To appreciate the magnitude of this claim, one must recall that the James Webb Telescope was not designed specifically as a SETI instrument. It is optimized for infrared cosmology, galaxy formation, exoplanet atmospheres, and distant object characterization. Its sensitivity, spectral resolution, and imaging capabilities do occasionally overlap with signals that could be classified as technosignatures, especially if those signals exist in narrow bands or modulate over time. In fact, theoretical work has calculated the detectability of artificial lights from exoplanets, showing that instruments like Webb might detect LED-type lights under certain optimistic assumptions. That research underscores the ambition behind treating Webb as a possible technosignature observatory, even if that was not its primary mission. It is important to emphasize that the interpretation remains speculative until further evidence accumulates. The boundary between unknown natural phenomenon and artificial structure is thin, and science demands careful demarcation. As additional observations arrive, alternative hypotheses, exotic chemistry, unknown cometary behavior, transient dust cloud interactions, or new fluorescence mechanisms might yet explain the light patches without invoking intelligence. The community will be cautious, critical, and demanding. But if even one of those patches is real, then we are looking at the first direct evidence of extraterrestrial engineering within the solar system. That changes everything. We would need to re-examine every comet, asteroid, and minor body through this lens, reprocess archival data for overlooked anomalies, and repurpose observational campaigns to look for artifacts. The hunt for life, for intelligence, would shift outward from exoplanet atmospheres to the smallest, darkest wanderers in our cosmic neighborhood. The discovery also prompts reflection on how we would respond. Would we attempt to intercept or land on the comet? Would we propose a mission to rendezvous and probe the illuminated zones? Would we broadcast communication signals toward the structure? Would we catalog and monitor it long term? The engineering, risk, and policy challenges are immense. Any spacecraft interacting with a comet risks contamination, damage by dust and sublimation, and navigational hazards. Safety protocols, planetary protection, and international consensus would be essential. The data streamed in silence, every photon counted, every wavelength logged, as the James Webb Space Telescope continued its gaze toward the enigmatic comet R2 Swan. What began as an observational program to refine brightness models and trace volatile activity was morphing into a revelation that could redraw the boundaries of human understanding. The artificial light anomaly, as the analysts had begun to call it, grew more distinct with every pass. The signal-to-noise ratio improved as more frames were stacked, and what once appeared as subtle irregularities were coalescing into patterns, structured, coherent, and impossible to mistake for random flare. Within the precision lattice of numbers, shapes began to take form. The light sources were not scattered randomly through the coma. They traced an arc along a specific region of the nucleus, a curved alignment almost symmetrical in layout. Each luminous point displayed a narrow spectral range, with a cutoff too abrupt to be explained by thermal processes. The emissions clustered around a few discrete peaks, each one corresponding not to natural atomic transitions, but to the wavelengths often associated with optimized illumination, bands that would maximize visibility while minimizing energy waste. The comet itself seemed to pulse faintly as it rotated, giving observers an impression of a deliberate rhythm. The sensation that something down there was operating by design sent shivers through those watching the telemetry unfold. Hours turned to days as the data pipeline filled. Every new observation deepened the enigma. Researchers at Mission Control began comparing the intensity variations of the lights to the comet's rotation period. They noticed synchrony. When the nucleus turned, the luminous arc brightened and dimmed as though the sources faced toward and then away from the telescope. It was not random scatter reflecting sunlight, nor was it the chaotic flicker of gas eruptions. The light curve possessed periodic consistency. This behavior implied that the sources were affixed to a solid structure, possibly embedded in the comet's crust or anchored to its surface. Even the faint thermal signatures detected at mid-infrared frequencies aligned with regions of the anomalous brightness, suggesting localized heating, perhaps by machinery or internal power generation. If these readings were genuine, they implied a form of technological construction within a body that had traversed the outer solar system for eons. The notion felt too large to absorb. Scientists, long trained to question extraordinary claims, found themselves whispering possibilities that sounded heretical only months earlier. They rechecked calibration references, ran simulations of dust jets, and replicated stray light effects to exhaustion. The anomaly persisted. No algorithm could recreate the consistency of the observed light pattern. In a lockdown virtual session, the project leads reviewed the findings in real time. Among them were spectroscopists, cryogenic engineers, and mission data architects, each representing decades of collective experience. Silence fell as the composite image of R2 Swan filled the screen, its nucleus bathed in faint glimmer, with discrete pinpoints glowing against the black backdrop. Someone noted that the brightest of these points aligned precisely along the comet's minor axis, forming a partial ring. It was as though a network of installations had been built to encircle one hemisphere, evenly spaced for stability or communication. The distribution hinted at geometry, proportion, even intention. Speculation inevitably followed. Could this structure serve as a power lattice, an antenna array, a habitat, or something beyond comprehension? Each hypothesis carried staggering implications. A ringed formation could harness centrifugal forces. It could stabilize a rotating core. It might even act as a phase system to emit or receive energy. If so, then the lights might not be mere illumination. They might be transmission nodes, communication relays, or energy emitters signaling across the void. The analytical team expanded the scope of the study, pulling data from other instruments. Webb's mid-infrared instrument revealed excess heat confined to the same region, implying active thermal management or waste heat from mechanical or electronic operation. The near-infrared spectrograph showed faint absorption troughs, inconsistent with known cometary ices, perhaps indicating artificial materials, polymers, metals, or composites reflecting and absorbing differently than natural regolith. Every clue led deeper into mystery. As scientists parsed these data, they began revisiting older comet observations from past missions. Had similar anomalies gone unnoticed? Comet 67P/Churyumov-Gerasimenko, visited by Rosetta, had shown unexplained electrical discharges and transient lights on its surface, phenomena dismissed then as electrostatic effects or reflected sunlight from ice. Now, seen through the lens of R2 Swan, those could be reinterpreted. Patterns once considered coincidence might reveal a broader, hidden architecture across multiple bodies. Perhaps comets had long been carriers of something more than frozen gases, maybe repositories, archives, or beacons waiting to be rediscovered. The discussions leaked into informal circles. Encrypted messages, anonymized summaries, and snippets of spectral plots began circulating among scientific institutions. Debates erupted in private channels. Some warned of premature conclusions. Others argued that withholding such a discovery from the broader community would be unethical. A few even proposed that if the lights were truly artificial, secrecy might be prudent until humanity could evaluate potential risks. That tension between open inquiry and existential caution permeated every conversation. Meanwhile, the comet continued its approach toward the inner solar system. Its brightness increased steadily, offering more opportunity for observation. As it neared the sun, solar radiation pressure intensified, creating dynamic forces on the nucleus. If any artificial structures existed, they would soon face immense thermal and mechanical stress. Scientists feared the illumination might vanish or flare catastrophically as conditions changed. A special observational campaign was hastily scheduled to monitor the comet's activity continuously through perihelion, hoping to capture any transition or event. On Earth, telescopes from Hawaii to Chile joined the watch. Data flowed into central archives faster than it could be processed. Each spectral frame was scrutinized for correlations. When visible light telescopes finally confirmed faint, discrete flashes corresponding to the infrared anomalies, disbelief turned to awe. The emissions appeared monochromatic, with color temperatures inconsistent with natural fluorescence. To the naked eye, the lights would appear bluish-white, steady, almost mechanical. Their spatial stability and recurrence ruled out spontaneous gas jets. Then, as rotation brought the same hemisphere into view over several cycles, the lights changed configuration. What had been a simple arc became a complex cluster, as though the sources had shifted or reoriented. That motion was too organized to arise from fragmentation or outgassing. Each point brightened sequentially, forming what looked like a pattern, a series of pulses running along the arc's curvature. The sequence repeated with precision, separated by fixed time intervals. Mathematicians ran analyses and discovered non-random distribution. The pulse intervals matched prime number sequences. Prime numbers. The universal language of mathematics. If that pattern were authentic, it would mean intentional signaling. No known natural process produces repeating prime intervals in electromagnetic emissions. The realization spread like wildfire among the research teams. Late-night sessions gave way to continuous monitoring. Every instrument capable of recording optical data was trained on R2 Swan. The light pulses grew stronger for a time, then stabilized at a constant repetition rate. The comet had become a messenger, broadcasting silently in a code older than humanity's first words. The implications were staggering. Somewhere within that frozen nucleus, a system existed capable of precise timekeeping, power regulation, and optical transmission. That required machinery, control logic, and an energy reservoir. A civilization, possibly ancient, possibly active, had placed technology within a comet orbiting our sun. The timeline was unknown. It might have been inserted millions of years ago, or could have arrived recently from interstellar space. The only certainty was that intelligence had intervened. Conversations among astrophysicists quickly turned from disbelief to urgent theorizing. How could a civilization insert such a system into a cometary body without destabilizing its orbit? Perhaps by capturing and reshaping the nucleus with autonomous machinery. Or perhaps comets were designed as vessels from the outset, constructed intentionally, their apparent natural appearance serving as camouflage. The energy demands of maintaining lights and signals were immense but not impossible. If advanced technologies utilized high-efficiency emitters, even modest power sources could sustain them over long durations. Miniaturized fusion cells, vacuum energy harvesters, or unknown mechanisms could suffice. Astronomers attempted to triangulate the direction of emission to determine if the pulses were directed outward, toward a particular point in space. Calculations suggested a preferred orientation aligned roughly with the galactic plane. That alignment could not be chance. The lights appeared aimed not randomly but with purpose, perhaps to communicate with something or someone beyond our solar system. Humanity might merely be an accidental eavesdropper, catching a glimpse of a signal never meant for us. Even as these ideas circulated, others speculated about motive. Why embed transmitters inside a comet rather than on a stable planet or moon? The answer might be mobility. Comets travel vast trajectories moving between the inner and outer solar system, even crossing interstellar boundaries over long timescales. They can serve as couriers, carrying messages or devices across stellar distances. A network of such comets could form an interstellar communication web, slow by human standards but stable and self-propelling. Each node could awaken as it neared a star, recharge using solar energy, transmit stored data, then fall silent as it retreated into the dark. In that light, R2 Swan might be a single operational node of an ancient galactic network. Its activation, its sudden flare of artificial light, could mean it had reached a programmed point in its orbit, or that it detected suitable observers nearby. Perhaps it sensed electromagnetic emissions from Earth, recognizing that a technological civilization had arisen and activated accordingly. If so, the timing was uncanny, the signal coinciding with the era of advanced telescopes capable of detection. The comet could have been waiting patiently for millennia for our instruments to mature. The ethical questions grew heavier. Should humanity respond? Could we, even if we wished to? The signal was optical, not radio. To answer in kind would require powerful laser arrays, capable of matching the emitted pattern. Yet any response might expose our presence, our level of technology, our location, to forces unknown. Some argued that the comet's illumination was itself an invitation, a test of curiosity and courage. Others warned it could be bait, or a remnant of a system long defunct, its creators gone or indifferent. The responsibility weighed on those who understood the stakes. While the world remained unaware, a small core of scientists and policymakers convened quietly. They debated whether to disclose the discovery publicly. Once verified, it would upend every paradigm in science, philosophy, and religion. The eventual confirmation would not be something a few experts could contain. Yet premature announcement could sow chaos, misinterpretation, or exploitation. The question of how to communicate such a revelation became almost as complex as the discovery itself. As the comet neared perihelion, the lights intensified again. Observers feared the rising heat would cause outgassing strong enough to disrupt the nucleus, but the pattern remained stable. Against the incandescent glow of sublimating gases, the artificial emissions shone steadfast, unwavering, as though shielded. In fact, the intensity compensated for increased background glare, maintaining consistent visibility, a feat suggesting active control. Even the dust plumes emerging from nearby regions followed curved trajectories, deflected slightly, implying electromagnetic manipulation or directed outflows. At one point, a secondary emission appeared, a narrow beam extending outward from the comet's illuminated arc. The beam remained steady for nearly 2 hours before fading. Spectral analysis indicated a narrow bandwidth emission near the near-infrared, perfectly coherent. It was, for all purposes, a laser. No natural comet process can produce coherent beams of light. This single event sealed the conviction among the observers that they were witnessing technology. If you liked this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us, what are your thoughts on James Webb finding artificial lights in R2 Swan? We want to hear from you. Thank you for watching, and see you next time.